Okay, so the answer to this was negative 13. So I don't know what happened there. Okay. Okay. No, that's right. Oh no. I don't hit back. Oh, I don't want to download the score guide. Darn it. Ah, okay. Good luck to me. Okay, question number 4. Um, find the average value. Okay, now it's finally average value. Oh, we did this one too, didn't we? Can you do question 12? Sure, let's jump to question 12. Okay, here we go. Question number 12. In an isosceles triangle with legs that are length s, the area is 1/2 s squared. Okay, we have a, this is s, so the area is ss 1/2 s squared. We're cool with that. At the instant where s is equal to square root of 32 centimeters, the area of the triangle is increasing. Oh crap, the word increasing, what does increasing relate to? Increasing is a fancy word for us in calculus for the word derivative, right? It's the slope. So we have a change in area, remember, so dA over dt, because they told us 12 square centimeters per second. That's why I use a dt on the bottom. Okay. What is the rate of, at what rate is the length of the hypotenuse of the triangle increasing in centimeters per second at the instant? Okay, so we have a rule for this triangle. It's an isosceles right triangle, so that's a 45-degree angle. So we know that's s square root of 2. Are we okay with that? Isosceles, and it's a right triangle, so it's a 45, 45, 90. Everyone cool with that so far? And they're asking for us, at what rate is the hypotenuse changing? So we'll say this is our hypotenuse, h. So we're looking for dh over dt. All right, so how am I supposed to get from area, okay, which is a is equal to 1/2 s squared, to somehow change that variable to h? Okay, all right. So they want, at what rate is the hypotenuse of the triangle increasing? Okay, so I'm going to do a couple things. First, I know this here. So we're going to take the derivative of this, but I'm also going to change the s to a different letter for us. And what is s? Looking here, s is equal to, s squared of 2 is equal to h. That's what the hypotenuse is. So if I want to solve for s is equal to h over square root of 2. Now I'm going to cheat here. I'm going to write a is equal to 1/2 s, right? But s is now h over square root of 2 squared. Okay, how do you feel about that? So there are a couple of problems with this problem that you have to catch. There's a lot of keywords here. Let me go ahead and screenshot this, and I'll show you guys the keywords if you guys haven't caught them yet. Oh crap, no, don't do it. Okay, a couple of keywords is first, they told us an area. Great, thank you. Wow, how nice of them. They told us the area of this equation. But they also said the area is increasing, okay? And increasing, we're automatically thinking, I'm automatically saying dA over dt is 12 centimeters squared per second, okay? They ask the follow-up question, what is the rate of the hypotenuse? So I'm thinking I need dH over dt. These are the things that I'm just automatically saying. They give me this, I need this. Now, how can I get from here to here? We know it's just the derivative. But if I take the derivative of this problem, dA over dt is equal to 2 over 2 s ds over dt. Are you guys okay that this would be the derivative from here? Bring down the exponent, so 2 over 2 s, chain rule, ds over dt. But that's not the variable we want. We want a dh dt. So what I said instead, that's change. Instead of doing this, that's change a to 1/2 with the h variable here. But how can I just change h for s is because we have a rule for isosceles right triangles. If it's s, s, s squared root of 2. So my hypotenuse is equal to s squared root of 2. Oh darn, I should record this. Oops. Oh, I am recording it. Yay. S squared root of 2. And then what we're going to do, we're going to just say, well, s is equal to h over square root of 2 now. H over square root of 2 squared, because this was a is equal to 1/2 s squared. So we just changed the variable. Now, after I've changed the variable, let me go ahead and get rid of this now. We can simplify this. I'm going to go ahead and simplify this before I do anything else. A is equal to 1 over 2 h squared over 2, which is 1 over 4 h squared. Now we can take the derivative. dA over dt is equal to 2 over 4 h dh over dt. Okay, great. Now, they gave us a couple of things. They told us that dA dt was 12. This is going to be 12 here. 1/2. What's the hypotenuse? Well, they told us that if s is equal to square root of 32, then h is equal to, remember we said is s square root of 2. So h is equal to square root of 32 times square root of 2. Square root of 32 times square root of 2 is square root of 64, which is just 8. We know we can plug in 8 here because that's a variable that we need, and all we have left is dh over dt to solve for. 12 is equal to 4 dh over dt, and then the dh over dt is equal to 3. How is that? Okay, so for problems like this, we actually did this before. Remember, these were rate problems, and we were able to take the derivative of what they wanted. And I made a big deal about just take the derivative of what they want. In this case, they had changed the variable from s to h, but we had an identity for that. Yeah, that's fine. Great. And a lot of times once you see, you're like, oh, I remember kind of doing something like that. And this is where we're reviewing again to do it. And we can see the answers to be there. Okay, can I get another question for that you guys need help with?
Mr. Go, I have a question.
Okay, let's jump to question number 14, which is here already. Oh my gosh, it's right here. Oh my goodness. Okay, the graph of which of the following functions has exactly one horizontal asymptote and no vertical asymptotes? Okay, so graph of which of the following functions has exactly one horizontal and no vertical asymptotes? So I'm trying to think if this is this just an algebra 2 question? Is there like a calculus way of doing this? So if you remember, to get horizontal asymptotes, we had 3 rules. And if the function, right, was something like x over x squared, if the bottom was bigger, our horizontal asymptote was y is equal to 0. Because the limit, as this goes to infinity, isn't the bottom so much bigger than the top? So it would bury it. Let's say 1 over 100, 1 over 1,000, 1 over a million, right? This takes you to 0. Right? That's one of our horizontal asymptote rules. The other horizontal asymptote rule was that if I write 3x over 4x, let's say plus 1, okay? So what does this graph look like, the limit as x goes to infinity of this graph here? Well, if I write 100, it's 300 over 401, okay? That's 3 over 4. What about 3,000 over 4,001? That's 3 over 4. And what happens is the idea is that we just cancel them out and we just keep the front coefficients if they have the same exponent. Hopefully you guys remember that rule. If you don't, that's as simple as what it is. Okay, so this horizontal asymptote would have been 3 over 4. Okay, and our last one is if the top was bigger, if f of x had something like x squared over x, do a plus 1 there just to mess us up. If the top is bigger, that means we have no horizontal asymptote. And then vertical asymptotes happen on the denominator. If it's 1 over x plus 1, the vertical asymptote happens at x equals to -1. Whoops. -1 here. Because if I plug in -1, we end up dividing by 0. So the problem that we see here is they're asking for which of the following, which graph, the graph of which of the following functions has exactly one horizontal asymptote, which it can only be, we only get one horizontal asymptote unless it was like probably absolute value, and no vertical asymptotes, okay? So let's look at A, 1 over x squared plus 1. This follows our first rule because the bottom is bigger. So we do have a horizontal asymptote at y is equal to, horizontal asymptote at y is equal to 0, okay? Great. And then do we have any vertical asymptotes? Can you make x squared plus 1 ever equal to 0? Answer is no. So we do not have any vertical asymptotes for this problem. So it looks like that's just A already. But the second one, just to make sure, 1 over x cubed plus 1. Does this fit our horizontal asymptote rule? Yes. The bottom is bigger. That means we have a horizontal asymptote of y is equal to 0. Now, this is actually factorable. X plus 1, x squared minus x plus 1. Okay, that was factoring a trinomial. No, sorry, factoring a difference of sum of two cubes. So we do have a vertical asymptote here at x equals to -1. Turns out this has a vertical asymptote, so this does not fit the criteria. The next problem is y is equal to 1 over e to the x -1. Does this have a horizontal asymptote? As x gets bigger on the right, this buries it, and if it goes bigger on the left, I think if it becomes a smaller number, right? So if I put e to the -10, right, that's a super small number. So we're left with 1 over 1. So if this graph looks like something like on the right side, it goes to 0. On the left side, it actually gets stuck at, if this goes to 0, we're left with -1 over -1. So we're actually kind of down here-ish. So I'm not sure what the transition is. But does this have any vertical asymptotes? Does e to the x minus 1 ever equal to 0? Does e to the x ever equal to 1? Yes, when x equals to 0, right? So it turns out we end up with a vertical asymptote at 0. And then the last one is, does 1 over e to the x plus 1, does e to the x plus 1 ever equal to, does e to the x ever equal to -1? Nope, that's not true. That doesn't happen. But do we have a horizontal asymptote there? I don't know. Let's look at the graph real quick. That's a good question. That one actually, I can't think of it as fast. So it's 1 divided by, and this was supposed to be a non-graphing problem, okay? So I'm cheating now. E to the x plus 1. Okay, so this actually has two horizontal asymptotes. Okay. Oh, whoops, I should know that. So this one, our first one up here had two horizontal asymptotes. The left one we have, it looks like we have two horizontal asymptotes. But the question asks specifically, they only want one horizontal asymptote. Okay.
So if we were on the AP test, would it be worth it to go through each one of those answers, even though we knew it was A?
No, you should just stuck with A. A was it. A was perfect.
Yeah.
I just wanted to go through them just so that we can get an idea. Just to refresh
Okay.
your memory on asymptotes and vertical asymptotes, horizontal and vertical. But the big deal is knowing the horizontal. I think that saves us a lot of time. And these have to do with limits. If the bomb is bigger, the bomb blows the top out of the water. That means we're going to 0. If they're exactly the same, we just copy the front and then the bottom. Now, the hardest part in this problem was because of those E problems. The E ones were the ones that were tricky. But I think once we realized on C that there's actually two asymptotes already, one was heading towards 0 and one was heading toward -1, then we realized there are two asymptotes, horizontal asymptotes there. So those weren't possible. Okay. All right. Can I help you guys out with any other questions? Okay, so problems like this, again, these are the questions that will have like, 20% of the people answer it correctly, right? Maybe like 30%, because people freak out when they see the problem like this. They're like, okay, I'm going to do the easy problems that look like, not like that, like this. I'm going to do this problem, okay, before I go and do number 11. So, okay, the weight of a population of yeast is given by a differentiable function y, where yt is measured in grams and t is measured in days. Okay, we got grams and days. The weight of the yeast population increases according to the equation. All right, fine. dy over dt equals to ky, where k is a constant. All right, that's the rate that is increasing. Thank you. Okay. At time t is equal to 0, the weight of the yeast population is, so y at 0 is equal to 120 grams. And it is increasing at a rate of 24 grams per day. So y prime is equal to 24 grams per day. Okay, which is our dy over dt, right? Because we're changing, y is grams, t is time, so it's our rate of changing grams per day. Which of the following expressions is an expression for y of t? Okay, so if this is our derivative, they want us to go backwards to find our y. Okay, and they gave us an initial condition. Let's go ahead and try it. If y prime is equal to 24, we take the integral of both sides, right? So y is equal to the integral of 24. But wait, here's our problem. That is our rate. Let me think. So if we start back here and we say dy over dt is equal to ky, okay? So for us to take the integral of this problem, right, is that sorry, this is a 0, okay? That's what it was, okay? Remember, the y's are on the wrong side. That's the biggest thing that we can catch right now. The y's are on the wrong side. And if they're on the wrong side, that's good, and move them to the right side. dy over y is equal to k dt. Everyone okay with that step? If the variables are on the wrong side of your derivatives, then you gotta swap them around. Okay, so we can take the integral of this on both sides now. Integral. So on the left side, we end up with natural log absolute value of y equals to k t, and then we're at a plus c on the right side, just because I'm used to writing c on the right side. My question for you, will y ever become negative? It shouldn't, right? Because the yeast isn't going to eat itself and then become a negative yeast in this weird alternate universe timeline. No. So we're going to say, hey, that's just going to be natural log of y is equal to k t plus c. Now it's algebra 2 time, folks. How can I solve for y? We're going to take the e to both sides, right? So we can e both sides now. Now, if you want also, you could just start plugging in values to find out what c is. So before we even do that, let's go ahead and plug in values to find out what c is. Now that c problem is what we have to solve for, because we have an initial condition. They told us the initial condition is that when t is 0, we have y is 120. Okay, so when t is 0, k times 0 is equal to natural log of 120. Okay, so we have plus c. So c is equal to natural log of 120. Okay, we got that part. So natural log of y is equal to k t plus 120. The k value is, what can we do with that? Let's see what we end up with right now. Let's go ahead and take the e to both sides. When you take the e, you have to remember that's all in exponent position. So we have y is equal to e to the k t plus 120. Now there's a trick here. There's the algebra 2 trick. If I'm adding exponents, okay, example, if I say x to the 3 plus 2, this is really x cubed times x squared, because I'm multiplying the powers. Okay, so if that's the case, I'm going to rewrite it. Y is equal to e to the kt times, whoops, I lost my natural log. I'm sorry. I lost the natural log. I forgot to write natural log. ln, I forgot it. I'm sorry. ln. Okay, I forgot to write ln there. Times e to the ln of 120. Okay? Do you see the mistake I did? I forgot to copy that natural log. C is natural log 120. I just was, for some reason, I just wrote 120. Now here's the cool part. If you remember e and natural log, they cancel each other out. And we're left with y is equal to 120 e to the kt. Now, which of these could be a possibility? Okay, which of these could be a possibility? It looks like the only choices are A and B. A and B. And which of these, if I plug in, if t is 0, if they tell me, okay, so if A was y is equal to 120 e to the 24 t, I think they would both give me 120. Y is equal to 120 e to the t over 5. They would both give us, okay, so both these would give us, yes. But then only one of them will give us, we have one more condition. Remember we said it's increasing at a rate of 24 grams per day. So which of these, if I take the derivative, would give us 24 grams? So the k value, oh, never mind, what am I talking about? The rate, that's the 24 here. That's what that 24 was referring to. That was our k value. So the answer is going to be A.
Wait, Mr. Ko, isn't it B?
Oh, is it B? Whoops. I'm not sure how we got 5 then.
I just took y prime from that last equation, 100 y equals 120 e to the kt, and then
Okay,
I
sure.
just plugged in 24 to y prime
Oh, 24 to y
and
prime.
solved for k. I don't know if that's
Oh, okay, yeah, okay. Okay, I see what you mean now. Okay, you're probably right. I was just kind of lost here, but you're right. Probably. Let me take a look. So, okay, so you said y prime from here. From this point here, we take the y prime. Y prime is equal to 120 e to the kt times the derivative of e is itself times kt would just be k, right? And then this here is y times k. And this is equal to 24. Is that what you did?
I just plugged in 24 to y prime
So
on the
it's
left side.
right. So it's 24 is equal to 120 e to the kt times k. Is that what you did here? And then you divided this over. So it's 1 over 5 is equal to e to the kt times k.
And t is equal to 0, I think.
And t is equal to 0 at this time. You're right. T is equal to 0. So e to the 0 is 1. So t is equal to 1 over 5. Okay, you're right. I was wrong. I got through like 90% of it and then I floundered out. Listen to Saphir, guys. Yeah, I was stuck with a K and I was thinking, oh, is that K just the rate? But I see what you mean. Let's see if I have. Oh, I know what I can do. Okay. All right, next question for us. So k is 1 over t over 5. K is, whoops, not k. Oh my gosh, this is k. That's k. That's k. That's k. K is 1 over 5. So y is equal to 120 e to the, we said kt, right? So kt, we're 120 e to the 1 over 5 t. My goodness. Okay. All right, next question, if you trust me. I wonder if there's a faster way of doing that. We had to plug in both the initial condition and the derivative there. Okay. That was question number 11. All right, what else can I help you guys out with? If not, you guys can get started on the next set of questions. But if you guys did get stuck, I know not everyone got a great score. You're right, the answer was B. There's that last part. Darn it. Okay. What else can I help you guys out with that you guys got stuck on? If you guys, hey, for you guys, I would recommend to do this problem again. Like you guys should just, you do the problem 3 times and it seems pretty easy. Like separating the variable, natural log to both sides, and then e to both sides. These are skills from algebra 2 that we have to make sure we remember. I wonder if I can see which questions you guys got wrong the most. Let's see if we can find that. It shows that 24 of you guys still have not done it. I don't know. Most of you guys got like a 750 to 75% on this. No one else? No other questions? We only have like 7 more minutes of class, folks. 7 more minutes. That's how fast class is. It's like you go to the bathroom and then you're back and it's already like done. Okay, let's see. What does this mean? Okay, what does that mean? No answer. Most of you guys have no answers. Most of these are no answers. Correct, incorrect. Let me find another that has a lot of incorrect ones. Let's do number 30. A lot of people got number 30 wrong. It won't call this a day. Okay. Hello. Okay, the region enclosed by the graph is y is equal to x squared and y is equal to 2x. So looking at a parabola, and 2x is a line. Okay. And that's the base, is the base for our solid. For each of the solid, the cross-section perpendicular to the y-axis is a rectangle whose height is 3 times the base. So the area is, the height is 3 times the base, right? The height is 3 times the base. So the area is base times height, or yeah, base times height times base. Okay, so we have 3b squared. That is the equation for our cross sections. Remember, the cross sections are going to be built out looking like this, coming out. If you want, you can draw one. It makes your brain work a little bit easier. Which of the following expressions gives the volume of the solid? So we're adding these cross sections up. So integral from, let's see, if I plug in, we want x squared equal to 2x here. And one of the things is, the hint is that if you look at the test questions, it's either 0 to 2 or 0 to 4. If I plug in 2, right, we are there already, right? So now they're equal. So from 0 to 2, integral from 0 to 2, our equation is we're adding up cross sections 3b squared, okay? And we're, to get the solid is area times a little bit of dx, right? A little bit of width. So here's our dx. We're heading, wait, which way do they want us to draw them? Perpendicular to the y-axis. Okay, perpendicular to the, here's the y-axis. So these are cross sections going this way now. Whoops. So I didn't completely read the problem because they want the y-axis, not perpendicular to the x-axis, perpendicular to the y-axis. So this problem goes the other way. So it's going from 0 to 4. That's 0 to 4. Let's change it because we're going the wrong direction. Integral from 0 to 4. The shape itself, we just need to figure out what this base is. So we're going this way. I'm sorry, going this way. So to find that base, you see I turned the picture around? It's right minus left. So the base is still 3b squared because that's what they wanted. And we're looking at dy. Now what's that b value? It's right minus left. So it's the parabola x squared minus 2x squared. They can throw out the 3 because it's a constant between 0 and 4. And then dy. Oh, I made a mistake again, right? Because this is in x, but they want y. So you can see you can catch yourselves doing dumb mistakes. Y is equal to x squared. That's x is equal to the square root of y. And y is equal to 2x. So x is equals to y over 2. So right minus left, it's still this equation. So it's square root of y minus y over 2 squared dy 0 to 4 and 3. Oh, the joys of multiple choice. Is there a way to view the questions after submitting? I don't know. Let me see if there's an option. I'll go ahead and research that to see if there's an option. If not, I can also always just send you the scoring guide. Or I can put that up for a little bit.
I think there is an option because another one of my teachers did that.
Okay, cool. Let me research that then real quick.
And Mr. Ko, our score on these practice aren't going to get like entered into Schoology, right?
No,
just
it's not going to be
track.
exact. It's like if you did a pretty good job, I will give you the credit. Yes. If you did a pretty good job, I'll give you the credit. I think what happens is after students can see results after scoring. Okay. Format online. See results. Huh. Wait, what if you don't do a good job? Then I I hope you do a good job. If you take off the secure browser, then we can see them after submitting. Oh, the secure browser part. Okay. At least we tried, right? There's a thing where you try to make your marriage succeed, but I tried. I really tried. Really. Okay, I tried. Some of these questions I cannot take off the lockdown browser for. That's why. I wonder if I can. No, I need to figure out how to do it. Okay, I'm gonna go research if I can let you guys see them specifically because they're in lockdown browser mode. That's why. Okay. All right. Besides that, you guys are good to go. If you guys get stuck on a question, please feel free to email me or we can talk about it next time I see you guys on Thursday. Okay. Oh, let's see. Can you pause before submitting the assignment if it's a secure browser assignment? Anyone know that? Can you pause and come back to it? Okay, yes, I hear yes. Thank you. All right, yes from 2 people. All right. Thank you very much, guys. You guys have a great day. Again, if you need help, let me know. If you guys want to stick around, let me know also. Okay, if you need something.
Thank you, Mr. Ko. Have a good
Bye.
one.
Thank you.
Hi, Mr.
Thank
Ko.
you. Bye.
Yes, COVID, yay. Bye.
Mr. Ko,
Yes, let's do
you can
Stephanie
go
first.
first. Yeah.
Sorry. I couldn't do the lockdown browser on my scholarship laptop.
Which laptop are you using? Are you using the old Lenovo Windows
No, I got a
PCs or
new
the
one in the
Chromebook?
beginning of the year.
You still got the Chromebook
Yeah.
one? And it's still not letting you do the lockdown?
It doesn't let me.
Have you done where you log out and log in using the lockdown mode?
I don't think so.
Okay. There's a thing where you log out of your user, right? And when you're logging into the computer at the beginning, you pick a different profile, and there's a lockdown mode for that.
Okay.
If I can find the directions, I'll email them to you. Okay. I think I can ask the tech guys for it.
Okay, thank you,
And
Mr.
then
Ko.
I'll increase the date on it for you. Okay.
I did it on like my personal laptop
Got
because
it.
I had no
Got it.
other choice, but
Yes.
better to have it on the school one.
Got it. Okay. Let me go ahead and see if I can find instructions from the IT guys. Okay.
Okay, thank you,
Thank you.
Mr. Ko.
All right. Bye. Okay, Dev, question?
Yeah, so a couple things. So I just would like to, so should I prepare to take it tomorrow just in case, or like, okay, I
What
have,
periods do you have off?
so this is the good news is that I don't have a sixth period.
Okay.
And I also could easily get out of first or second because first period I have English and he just reads to us. And so he would let that slide for sure. And second period is jazz band. So I could totally,
So why don't we aim for period 6? Because after 6, if you're not done with it yet, you can still continue for a
wait,
little bit longer.
but
Because then
six
yes,
is, when does six start again?
6 starts at 12:30.
Okay, so I can only do that on a day where that's not Tuesday or Thursday.
6 period is always on Wednesday and Friday.
Could we do Friday? Because on Fridays I don't have to show up till 2:30 or 3.
For
But
practice, you mean?
yeah, but on Tuesday and Thursday I have to show up at like 1 for a game.
Tuesday, Thursday, you said. Can we do it on because you still have to get to school for practice, right? But you could be late to practice for a little bit.
Yeah,
Right.
no, I'm saying if we did it on Friday and we did, what did you say, 12:30?
Yeah, 12:30.
That would be fine because if I do, I don't have to be at practice until 2:30.
Okay, sure. Why don't we aim for this Friday then? And then
Okay, cool.
email me and I'll email you the Zoom link.
Okay, cool. And I'm sorry if I'm a bit slow on this new stuff.
Uh-huh.
It's just because
You're
I'm
catching up,
preparing
right?
and I'm catching up CUDA, but I'm getting
All
on
right.
it.
Okay,
So,
sure. Got it.
all right.
Okay,
Appreciate it.
thanks.
Cool. So Friday is good. Thank you
Yep.
so much.
Okay. Bye.
Bye bye.
Mr. Ko.
Yes, go ahead, Lena.
Yeah, I wrote you like a long note there, message. in
Oh
the
yeah, I
chat.
did read it. I did. I was trying to read it while doing this, and then I stopped reading. I was like, forget it. Let me go back and read it.
Sorry.
Right now you have a C, I think. Right now, Lena.
Not a D.
Oh really? Whoops. Why is it a
Yeah.
D?
Because
Did
of the CUDA, the last CUDA assignments and the test 30.
Okay, you didn't take test 3 or what? Or you just did
Yeah, I was
badly?
absent that day.
Okay, so you have to sign up for the retake to take it. So right now, I'm going to give you a C right now, and then you can bump up your grade once you take it. Okay.
Yeah, I'm just wondering if you'll give me like full credit for the thing, or you're gonna count it as a retake.
It's been a while, right? It's been like over a week now. Why didn't you
Yeah,
take it
but
like last week?
I wanted to take it on Wednesday, but like I forgot because it wasn't we didn't have class that day, so I just forgot that
Okay,
it's after school.
I'll just set it up for I'll give you 90 out of 90. Okay.
90? Oh.
Yeah. So if you get an A, it'll bump up your grade. But we'll see. We'll see how you do. That's to see how you do. Okay.
Okay, but let me just ask this: if I get 100, would I get 100?
I don't know. We'll see how you do. We'll see what your work looks like.
Alright.
Okay.
Thank you.
Okay. Bye.
Oh wait, so
Go ahead.
is it tomorrow?
If you want to, if not, you can take it
Yeah.
next Wednesday. That's fine also.
No, tomorrow.
Okay, just go ahead and sign up for it. Okay.
All right, thank you.